in this 45 minutes, I'll be providing you information on who INCOZOLs are, an insight on oxazolidine and its chemistry, and how can you improve the performance of one component and two component PU coatings using oxazolidines in different applications. Now moving on to who INCOZOLs are. INCOZOLs was founded in 1986 with R&D, head office and manufacturing facilities located in Preston, United Kingdom. INCOZOLs is an industry-leading specialist manufacturer of oxazolidines, polyurethanes and epoxy technology, which are globally supplied to the producers of coatings, adhesives and sealants. Products INCOZOLs offer are oxazolidine, which is our INCOZOL range, which is a versatile additive for polyurethane coatings. We also manufacture Disperse range, which is pyridine-free polyurethane dispersions, and we also manufacture waterborne epoxy curing agent for manufacturing of high-performance floor coating applications. Now moving on to what are oxazolidines and what are its functions. Well, oxazolidine is a 5-membered heterocyclic ring structure containing nitrogen and oxygen as shown in this diagram. It is a versatile additive for both one component and two component solvent-borne high solid polyurethane coating systems. So what are its functions, or how does oxazolidine work? Well, all oxazolidine work as a moisture scavenger. As a moisture scavenger, oxazolidine hydrolyze and ring open in presence of water or moisture to produce an amino alcohol and an aldehyde. This amino alcohol groups will then react with the isocyanate containing binder to produce a polyurethane and polyurea linkages as shown here. Depending on the structure, oxazolidine exhibits more than one functions. That is, along with the moisture scavenger, it can be used as a reactive diluent in two-component polyurethane coating systems to reduce the VOC and to reduce the viscosity. And it can be also used as latent curing agent in one component system to promote faster through cure. As a formulator, you have come across many defects, and particularly as a PU formulator, the most common defect you come across is pinholes. In this next few slides, I'll be explaining you what is the cause of the pinholes and how can you resolve, and particularly in two-component PU topcoat application. Where would you see this kind of defect or pinholes? Particularly in the applications like wind turbines, automotive, aerospace and military, which are subjected to a harsh environmental and humidity conditions, you see this kind of defects. These applications are applied via two-coat application. That is, the first coat is your epoxy primer, and this primer is then overcoated with a two-component polyurethane top coat. Typically, this two-component polyurethane top coat consists of acrylic polyol or polyaspartic esteramine, and as a part B, it consists of an isocyanate hardener, for example, aliphatic HDI and IPDI. So what is the reason, or what is the cause? Why does this defect occur in the first place? The main disadvantage of using isocyanate hardener is that preferential reaction with water, which generates carbon dioxide gas as shown here. Once the coating is fully cured, the CO2 which is generated is remained in the film, and this causes the defects like pinholes or foaming and inconsistent gloss as shown here in these pictures. So how can you resolve this? This is the most important thing in terms of how can you resolve this issue. The one way to resolve this issue is to stop the reaction of the isocyanate with water, and which can be done by incorporating an oxazolidine moisture scavenger. So what is the role of a moisture scavenger? Well, the role of a moisture scavenger is to prevent the generation of carbon dioxide and the problems associated with the moisture contamination. INCOZOL offer INCOZOL 2 as a moisture scavenger. INCOZOL 2 is a very effective moisture scavenger. The reaction of INCOZOL 2 with moisture is faster reaction than the one of isocyanate reacting with water. That is, INCOZOL 2 preferentially react with water over isocyanate. So basically it's like a race. It's a competing reaction. So INCOZOL 2 has to win this race to get rid of the problem like pinholes. So what are the benefits of using INCOZOL 2? We carried out an internal study where we applied via spray application 2-component acrylic PU paint with and without INCOZOL 2 as shown here in this picture. The picture on your left is without INCOZOL 2, and as you can see it's full of pinholes, whereas the picture on your right is with INCOZOL 2 and it doesn't have any pinholes. These panels were then subjected to anti-corrosion provision test for 2000 hours, and it's clearly observed in this picture. The panel on your left, which is without INCOZOL 2, the corrosion has observed through the pinholes, whereas the panel on your right, which is with INCOZOL 2, is still intact. Thus, by addition of INCOZOL 2, you can improve the coating integrity. Addition of INCOZOL 2 not only prevents the carbon dioxide gas, but it has no detrimental impact on the film properties. So, for example, by addition of INCOZOL 2 in this particular system, the formulation viscosity is reduced as shown in this graph, and this will help for the ease of application. Along with that, the pot life also increases. So by adding INCOZOL 2, you can improve or increase your pot life, but without having any detrimental impact on the drying time, which is also a benefit. The other benefit which INCOZOL 2 provide is that your ultimate hardness improves as shown in here in this graph, where by addition of 2% INCOZOL 2, the ultimate hardness increase. The reason being that INCOZOL 2, once hydrolyzed, it ring opens and produces amino alcohol group, and this amino alcohol group, as explained earlier, will react with the isocyanate to produce polyurea and polyurethane linkages, and thus improves the ultimate hardness. So to quickly summarize, INCOZOL 2 works as a moisture scavenger and prevents the generation of carbon dioxide gas, leading to a defect-free film. But the addition of INCOZOL 2 does not have any detrimental impact on other film properties. The viscosity and the color of INCOZOL 2 is very low, thus it can be used in high solid and the clear coat systems. As you all are aware, the VOC legislations are becoming very stringent nowadays. As a formulator, it becomes very tricky and challenging to reduce the VOC, and particularly in the applications where 2-component polyurethane top coats are used. So the applications like wind turbines, automotive, aerospace, and military uses a 2-component polyurethane top coat, and this top coat is generally spray applied. And to have this application, for spray application, you need to have a low viscosity, and for this you need to add solvents, and thus by adding solvent, this becomes it becomes a non-compliant or a non-VOC compliant product. So how can you resolve this basically? And the one way to resolve this is to incorporate an oxazolidine reactive diluent. So what are the key requirements of the reactive diluent? Well, it should have an excellent cutting power, which will reduce your VOC. It should have a good compatibility with polyol and solvents. It should have it should provide a defect-free films, and it should have a low viscosity. INCOZOL offer INCOZOL LV for this kind of application. INCOZOL LV is a bis-oxazolidine reactive diluent with 4 functionalities. Even though it's 4 functional, the viscosity of INCOZOL LV is very low, that is only 50 megapascals. So how can you incorporate INCOZOL LV in the system? In terms of the 2-component system, the part A, which consists of a polyol, which is then modified with pigments, extenders, and additives, thus the viscosity of your part A increases and it becomes very difficult to apply. So the recommendation is that to replace your 10 to 30% of your polyol component with the reactive diluent, that is INCOZOL LV, which will overall reduce your viscosity and in turn reduce the solvent demand to produce a VOC compliant high solid products. Here is a graph which shows that by adding 10 to 30% of your INCOZOL LV, the viscosity of your polyol reduces significantly. Here is another graph which shows that by addition of the replacing your polyol with INCOZOL LV increases your percent solids and thus reduce the VOC. So to quickly summarize, INCOZOL LV works as a reactive diluent, and thus by replacing 10 to 30% of your polyol, you can formulate a high solid low VOC coating. It exhibits more than one function, that is, along with the reactive diluent, it works as a moisture scavenger as well. So it prevents the generation of carbon dioxide gas, which will lead to a defect-free film. It is multifunctional additive and has a very low viscosity, and thus it's suitable for spray applications. Now moving on to from two component system to a one component system. In next few slides, I'll be explaining in terms of how can you avoid foaming and how can you promote faster through cure in one component aliphatic moisture cure high build coating systems. Typically, where one component aliphatic moisture cure PU coatings are applied are over roofs, balconies and floors. Typically, one component moisture cure aliphatic system consists of an IPDI pre-polymer, which is modified with pigments, extenders and fillers. As a formulator, there is an advantage of using one component over two component applications. The main advantage of using one component over two component alternatives is that you do not require any specialist equipment or any specialist tool or mixing tool before the application. And the other important benefit is that applicator can apply at their own leisure. There is no pot life issues. So the reason being that the reaction occurs after the application, so there is no pot life involved. But the same disadvantage as two component system one component has, that is, because we use an isocyanate hardener, the preferential reaction with water generates carbon dioxide gas, and once this carbon dioxide gas or the film is fully cured, the gas remains in the coating as shown here in this pictures to produce foaming, pinholes and inconsistent gloss. So how can you resolve this issue? Well, one way to resolve this issue is to add an oxazolidine latent hardener. So what is a latent hardener? A latent hardener is an inert additive until exposed to moisture. It hydrolyzes and ring open in presence of moisture, producing amine and hydroxyl group, which will readily react with any isocyanate present, and thus it produces polyurea and polyurethane linkages and stops the generation of carbon dioxide gas, providing you a defect-free film. INCOZOL offer INCOZOL 4 and INCOZOL EH as a latent curing agent. INCOZOL 4 and INCOZOL EH are bis-oxazolidine latent curing agent with 4 functionalities. I would like to discuss something about manufacturing and handling of oxazolidine latent hardeners in general. All the raw materials which are used to manufacture one component aliphatic high build polyurethane coatings are moisture sensitive. So the recommendation is to avoid moisture during manufacturing as much as possible. The moisture can be avoided by using an enclosed vessel and using a vacuum or a nitrogen blanketed during manufacturing. In terms of handling the oxazolidine latent hardener and oxazolidine in general, it is recommended that as soon as you open the drum of INCOZOL, please nitrogen purge it and then reseal it to have a good shelf life. So what are the benefits of adding latent hardeners in one component high build PU coating systems? Well, the important benefit is that it works as a moisture scavenger to get rid of the carbon dioxide and to produce a defect-free film. As shown here, the picture on your left is without a latent hardener and it's full of foam, because particularly when you apply in a high build coating environment, foaming is an issue, whereas by incorporating INCOZOL EH, there are no defects. One of the key benefits of using oxazolidine latent hardener is the ability to accelerate the through cure in this kind of systems, as shown here in the graph. By incorporating the latent hardener, the touch dry time and the walk on time significantly improves and reduces. Thus, it promotes a faster through cure in the high build coating systems. The other benefit which latent hardener provides is that it improves the durability through cross-linking. That is, it improves your final hardness as shown here in the clear system as well as in the coating system, and also it improves the ultimate tensile strength. It also improves the overall chemical resistance. The chemical resistance against acids, alkalis, and solvents is significantly improved, and also the stain resistance against the common household like coffee, red wine, and ketchup is significantly improved. Now I would like to share a video which shows by how Oxazolidine latent hardener works.
The abbreviation MTC stands for moisture-triggered chemistry. This refers to a moisture-triggered curing system with many advantages in application. The following animation explains the principal function of this technology in comparison to conventional waterproofing systems. Both systems make use of the environmental humidity, here implied by the grey cloud symbol. On the right, the innovative MTC coating. On the left, a conventional liquid membrane. The main advantage, the MTC coating is rain resistant and watertight immediately after application. The water from the air humidity reacts immediately with the isocyanate containing binder of the coating. The freshly applied coating forms a skin, which becomes thicker and thicker during the curing process. The curing process starts immediately and proceeds from top to bottom. On the other hand, conventional polyurethane coatings show a significantly slower, irregular curing progression. Rain or extreme humidity can therefore cause disruptions of the reaction mechanism. CO2 bubbles appear. Even foaming and blistering may occur, particularly in the case of thicker layers. In contrast, the innovative MTC technology makes use of the reaction of a specific hardener with the environmental humidity. This does not release any CO2. Consequently, no blisters occur.
The special hardener mentioned in the video is the Oxazolidine latent hardener. So to quickly summarize, how does latent hardener work? Where latent hardener provides and improves and prevents the generation of carbon dioxide gas to promote a defect-free film, particularly in one component high build coating systems. They are multifunctional hardeners, and thus it provides a faster through cure, which leads to a improved and ultimate tensile strength and gives you a final better hardness. Finally, Oxazolidine is an additive offer great advantage in polyurethane coating system. That is, it's a versatile additive which can be used for both one component and two component system. It also is a multi-purpose additive, that is, works as moisture scavenger, reactive diluent, and latent curing agent. It also enhances the performance by preventing carbon dioxide gassing, and it reduces both VOC and energy cost. At INCOZOL, we aim to build a strong relationship with our customers. One of our main strengths is providing technical support on how best to use our products. This is particularly important when using Oxazolidines. For more information and guide formulations, please contact INCOZOL directly, or for all the other information like guide formulation, which are available on Special Chem Oxazolidine Center as well. Thank you for your attention and participation.